Welcome friends, in this one we're going to explore the concept of subspaces in linear algebra. Sounds fancy at first, maybe mysterious. Let's put down the definition parts. So the first part is this one. A subspace, read it very carefully, a subspace of a vector space V. So that's your bigger object. Stop for a second. The vector space V is your bigger object. So how do we depict it? Somewhat generically, for now, you could just depict it as follows. Just draw a plane like this. For example, you see? It's a bit tilted. Gets the idea across. So imagine that this is your V right here. It's this vector space. Then it says a subspace of a vector space V is a subset H of V. So because it's a subset H of V, what would that tell you? That it's located somewhere within here, you see? So a subspace of a vector space V is a subset H of V that has three properties. Let's write down these properties and illustrate them stage by stage. So the first property is this one. The zero vector of V, read that carefully, the zero vector of V. So put this down as a zero vector somewhere within V. For example, a dot. Imagine that represents the zero vector of V. So the zero vector of V is in H. So now, how do I mark H? H has to contain the zero vector of V. So if I mark H as a line, it has to be something like this because it has to contain that zero vector. On the other hand, if you do something like this, right there, that's not a subspace because the issue with the green line is that, as you can see, it doesn't contain the zero vector, which is indicated by the dot. So let's add this as a note here. Not a subspace. Space. Because it doesn't contain the zero vector. Let's make that writing a bit smaller so it fits better. Next one says that H is closed under scalar multiplication. So in other words, what does that mean? That means the following. For each vector U, so I'm going to make that bold. Vectors will indicate by U in bold this way, for example. So each vector U in H, C this way. The U there is getting multiplied by C, a scalar. So just imagine like a number like 5 or 10, negative 2, whatever it happens to be. So this is C times U is in H. So what does that mean in practice? What I'm going to do is I'm going to take this, I'm going to group these objects. I'm going to kind of make a copy of it down below. This way. Now let me ungroup them back. And we need to get rid of some things here. I don't need this anymore here. Let me remove it. So I'll delete that. The same thing with the bit of this text here. And now you have H and you have this line through the zero vector, and to be closed under scalar multiplication means the following. If I draw a vector this way, which is a vector in H, it lies along that line, that's all that means. Now let's do this. I'm going to make a copy of this vector here. I took it out of H, and all we have to really do is just produce a scaled version of it. That means a longer version of it. So in other words, when you do that, you do this. Do not change the direction, just the length, like this, you see? And if you wanted to, you could label things. So imagine that this is U, the original vector. Let me make that bold. Right here. Then this new vector that I've drawn, that is longer, is basically C times U. This way. And again, that should be bolded because it's a vector this way, see? So it's a scalar multiple of it. So now what I can do is, let me take this and I'm going to move it back into the picture. And this is what's happening now, see? Let me assemble the pieces right there. So U is a member of H. CU, however, is also a member of H. The fact that I chose to basically suggest by drawing the arrows this way that C has the value, that it has a value that's more than 1 is okay. And the last part is probably the most elaborate. So let's take a look at the next and last part here. H is closed under vector addition. And that is, for each vector U and vector V in H, the sum is in H. Okay, so let's take a look at this. Now remember, these are vectors, so this right here, bolded. Or you can put arrows above them. Some people bold, some people put arrows. So let's depict this definition in a picture. So take this picture from here. Alright, so I'm going to make a copy of this whole thing, move it down. That's the nice thing about computers. And then get rid of these parts. Kind of over to the side, delete them. And what I'm going to do is take a look. I'm going to draw a vector in H, right there. That's a vector in H. So for the sake of concreteness, let's refer to it as U. So here's the vector U. Alright. Now, This talks about two vectors u and v, so we also need a vector v. So I'm going to draw here a vector v. Say for now, just pointing in the opposite direction. Why not? This way. So let's call that vector v. Let's bold this. So that's v right there. And now, look at the definition. It says that the sum of the two is in h. So let me just make a copy of these off to the side. So this is one of them. Take this one over here. How do you do vector addition? Well, if you just follow the basic principle of vector addition, you take one, right here, this one for example, and you move it and you put where it begins, its starting point, at the tip of the other one, this way, right there. The resultant is what you get from adding them, so in this case, that would be represented by the following. I'm going to use this grayish color here, but make it a bit thicker. That would be this part right there. You see this little arrow that I've just drawn? Now notice something about this arrow. If I take it now, notice it has the same direction as the other vectors, you see? In other words, here it would look like this. This would be the sum of the vectors right there. That gray arrow. And what's important is the fact that that arrow lies along the same red line. So this is an example then of what it means to be closed under vector addition. Let me emphasize this. So this is going to be u here, plus, and then v. So let's bold that also this way. So this is u plus v. It's that little gray arrow that you see in the picture. Let me move this a bit closer right there, you see? Alright, we don't need this. This was just scratch work to help us form the sum correctly. Notice that u plus v lies along the red line. But these are the major components of the definition of a subspace in linear algebra. So what I'm going to do now is the following. Friends, I've zoomed out here so you can see all of the different pictures and the parts of the definitions. So thank you. Please leave a like and subscribe. I'll see you in another video.